Hello!
Hey guys, welcome back to our channel. Today we're going to be talking.
Hi, how are ya?
Today we're going to be talking about solutions and molarity. I'm Bella and this is Faith. And first things first. You're probably wondering, what is molarity? Well, molarity has to do with moles, and moles are scientists' way of counting the number of particles there are.
Molarity is a concentration measurement that uses moles.
So molarity is basically just another word for concentration.
Molarity measures how concentrated the solution is based on the number of solute particles dissolved. The formula for molarity is equal to the moles of your solutes. Then that's divided by the liters of your solution.
So, M equals N divided by V, where M is molarity, and the N is the number of moles of a solute, and V is the volume of the solution in liters.
Molarity can also be used as a conversion factor because it has two different units, allowing you to go from one unit to the next. Let's do a practice problem. Now, let's head over to our lab.
Let's do a practice problem. The question is, what is the molarity of a 125 milliliter solution containing 0.050 moles of hydrochloric acid? Before we start, we need to address what is given and what we are solving for. It's asking, what is the molarity? So, we're solving for molarity. 125 milliliters is the volume, and 0.050 moles is the number of moles. Now write down the formula so you can fill in the blanks to write the appropriate equation, M equals N over V. Since M is what we're solving for, we don't need to rearrange the equation to solve. Now let's place what's given into the problem and put 0.050 moles into N. And divide that by the volume. However, you may be tempted to write 125 milliliters into the volume, but that would be incorrect.
That is not correct. Because according to the encyclopedia...
Since V is the volume in liters, not milliliters, we need to convert. In order to convert 125 milliliters to liters, you can multiply it by a conversion factor fraction. Since 1 liter is equal to 1,000 milliliters, we can put 1,000 milliliters in the bottom and 1 liter on the top. So, 125 times 1 liter over 1. And that comes out to 0.125 liters. Or since we know that we're working with the beginning front of the word, you can take 125, and milli means 1/1000th, so you could just move it over 3 decimal places, which is a place for every single zero, which would make it 0.125 liters as well. Now that we know V, we can plug it back into our equation. And that total comes out to, after you plug it into your calculator, 0.40 moles per liter. That's it.
Now, let's talk about the standard gas law. The molar form of the standard gas law is represented by the equation PV equals nRT, where P is the pressure of the gas, V is the volume taken up by the gas, T is the temperature of the gas, and R is the gas constant, and then N is the number of moles of the gas.
The most confusing thing about the ideal gas law is making sure to use the right units when plugging in numbers. Make sure pressure is always in atmospheres, ATM, or millimeters of mercury, mmHg. And volume is always in liters, and temperature is always in Kelvin.
Now let's do a practice problem. Now let's go to the lab one more time.
The question is, if I have 21 moles of gas held at a pressure of 78 atm and a temperature of 900 Kelvin, what is the volume of the gas? So we're solving for volume because that's the unknown in the question. Given to us is 21 moles.
It's 9 plus 10.
21.
You stupid.
Which equals N 78 atm, which equals the pressure, and 900 degrees Kelvin is the temperature, and 0.0821 is the gas constant, which is R. So now we can take those numbers and plug them into our equation, which is PV equals nRT. Since we are solving for volume though, we will have to rearrange our equation to look like this. V equals nRT over P. So, let's plug it in. 21 moles times 0.0821 atm times liters over times Kelvin times 900 Kelvin all over 78 atm. Make sure to cancel out like units to end with the correct unit of measurement. So moles, Kelvin, atm. Now we rewrite it to where V equals 19.89. That's what you get after you type it into your calculator.
Hello, hey, how are ya?
We're back. All right, now that we know about solutions and molarity, we are finally
this much. All the girls stop.
chemists.
Time for science.
Rock and roll.
We hope you all learned something, wrote down some notes, got a little smarter, got a little bit more genius. So, see you next time.
Bye, guys. Oh.
Molarity.
We should like